So in this video, we're going to talk about linked lists. It's really our first real live data structure that we've talked about in this class. We've done some other things to get us ready, but now we're getting ready for the big time. Okay. So a linked list we're going to talk about, it's a collection of nodes that each contain data. Okay. So they have some very special properties. I'm going to try to draw with my mouse, which is fun. Okay. So we're typically going to have some kind of a pointer, okay, called either the root, sometimes it's called start, different things, okay? So this pointer is going to go to a series of nodes, okay? And I like to draw nodes in this way, okay? So for each of these nodes, we're going to have a couple of parts here, okay? This is going to be either the data or the info, depends on what people call it. And this is where you're going to store something, like you may have a 10 located here, okay? This next part is going to be called either the link or the data, and it's going to take us to the next node, okay? So you can have a series of nodes that are connected, okay, with whatever we have stored in each of them. Okay, that's the idea. It's a linked list. They're linked together. Okay, let's say this is a 7. Okay, and then we put that to show that we're at the end. Okay, so this root points to the first one. Okay, so this may look like a array, right? Very similar. We have items together, but there's some differences here, and the differences are what we can't do and what that means that we can't do them. Okay, so if we lose the root, we can only get to the others or to any of them once we're at 1. Okay, so to get to 7, these have to be sequential. We can't directly get to 7, so there's no direct access. Okay, we can't say linked list bracket 3 or bracket 2 in this case and go 0, 1, 2. It doesn't work that way. Okay, we have to follow the trail all the time. So we always have to start with a pointer to the first element, then the second, then the third. Okay, and this seems like a disadvantage. Why would you want to do this when you're limiting your functionality? And the difference is that if you have a really roughly drawn map of memory, okay, if you're going to do a normal array, you have to have a block of memory that's contiguous, right? That's how arrays work. Okay, the array name would just point to that very first memory address. Okay, if we have an array A, okay, then it would have however many markers there are. We're supposed to go all the way up, but I'm drawing my mouse again to store those. Okay, but they all have to be together, so it's not very efficient. Okay, where when we're talking about a linked list, we have the ability to put our little nodes, if it's an inside node, wherever. We can use memory in any way that we want, okay? And then we just keep a pointer to that first item, okay, to here. From there, we go wherever we want. We can go, to there. It may go from there to there, and there back to there before it's done, okay? So it's the idea that we have this flexibility to use all the memory and we can move things around as we want, okay? It's a good choice for data where we're always going to be going in order, okay? It's always going to be sequential, okay? If you need random access, this is not the way to go, okay? And you're much better off using a different data structure, okay? But if this is what you need, it can be pretty effective, pretty efficient, I guess it's really what it's doing for us, okay? So let's take a look at how we're going to code these up, okay? So just go with a linked list CPP example, okay? So of course we always have to include our IO stream. I'm going to do our using namespace standard. Okay. But before we do anything, we're going to go ahead and create a struct. So remember, a struct is like an abbreviated class. Okay, so I don't have all the functionality. I don't have any methods. I don't have public and private, but it is a way to collect different pieces of information together. Okay. So that's what we're going to be doing here. So we're going to call this node type. Okay. And it's going to contain two pieces of data. In this case, we're going to have the info that we're storing. Okay. So we're going to create a linked list of integers. Could be a float, could be a string, could be whatever you want. But this keeps it simple. Okay. And then we're going to have a pointer to a node type. Okay, so the asterisk there means it's a pointer to a node type, okay, called link. Okay. So going back to the picture, the info is on top, the link is what's on bottom, and it's going on to the next thing. Okay. And if we wanted, and I forgot, you got to put, just like a class, we got to have that extra semicolon there. Note that if you're using Emacs, Emacs is going to not space things out correctly if you don't have your punctuation correct. Okay, so that's worth keeping in mind. Okay, if you wanted to declare something, okay, we could do something like node type head. That would be just declaring a pointer to a node right there. Okay, and we can do that when we're setting up our list. Okay, so that's going to give us the basic structure here. Okay, and then when we're looking at a linked list and we're trying to figure out the different things that we want to do for it. Okay, so let's, this is kind of hard to see. I'm going to actually switch over. I've got the textbook here, so let me point over to the textbook so I don't have to draw graphs again. Nobody wants me to see that. Okay, so let's go to here. Okay, so this is from the textbook. So here's the code I just put in there. Okay, and there's a variable declaration. Okay, so again, they're trying to help us to understand the way this works here. So we have this head pointer, okay, and it contains the value 2000, let's say, because 2000 is the memory address of the first node. So unlike me, they do their nodes right to left instead of up and down, but that's okay. So here we have the info that we're containing. So the first node contains a 17, that's the info. And then there's a link to the next node, which is at memory address 2800. It has a 92, which then links to one with a 63, which links to one with a 45. And they're using this down arrow where I use a backslash, but same basic idea. Okay. So head or root, pick one, stick with it, and you're okay. Okay. So the value of head here is 2000. That's the memory address where the first node of our linked list is located. Okay. So head info means we go to 2000, we look at that node's info, okay, it's going to be equal to 17. Okay. Head link will be equal to the 2800 in this example. Okay. If we were to look at head link info, so there's head points to here, head link points to there, head link info would be 92. Okay. So that's kind of how that works. Okay. We're also able here to create, if we have another pointer of the same type called current, we can make it equal to head. Okay. So we don't lose our head basically. Okay. So that's what we're talking about there. Okay. If we have this current now, okay, current was declared as a pointer to a node. If we say current equals current link, what that does for us, that's just going to move us one down the line. We'll be able to iterate through. Okay, so we start with head here, pointing to this one. If we have head or current equal to head, current and head both here or pointing here. Okay, we don't want to mess with head. We want to leave head where it's at. But if we say current is equal to current link, current now points here. So current info would now be 92. We could then say current equals current link again, now point to this node, and now current info would be 63. We can also do things like head link link, head link link link, head link link info, all those things. Okay. So that's the basic idea of how this is going to work, okay, to give us a graphic picture. Okay, so let's now go back and take a look at the code again, okay? So when we're looking at trying to figure out how these work in code, okay? So we can do things like, again, we can say that current be in somewhere, let me be in int main. Okay, and again, I've not, this is just going to be code snippets because we haven't really put a program together yet. Okay, but let's return something. Okay, because we don't have a struct head or anything. But if I were to say something like current equal to head, once I have a head, once I've declared something, okay, then I could do something like while current does not equal to null pointer. Okay, and null nullptr is a thing that's built in that means it's an empty pointer. Okay, you can then inside of this do whatever you want to process the list. Okay, so this allows us to iterate through every element of the list all the way until the end. Okay, if you wanted to go through and print out all the data stored in the list, then what you do in here would be, so again, current first points to head, and then every element past that. So the first element, second element, and so forth. So each time around, you could just see out current. We're going to use that arrow notation, okay, to info. Okay. Okay, that would go through and print out the element. Okay, but now I have to make sure that I'm doing the movement to the next one. I'm going to have an infinite loop. So current is equal to current link. Okay, and that would go through the element one item at a time, printing out each one. Okay. So if we're going to look at some more code here, again, this is not yet in a program yet. We can think about the kinds of things we'd like to be able to do with our list. Okay. So we'd like to be able to insert an item into the list. Okay. We'd like to be able to maybe delete an item from the list. Okay. So we're going to think about some ways that that we could do that. Okay. So as part of a lot of this, so a lot of these kinds of operations, and again, all code snippets, not real code yet. Okay, we're going to start by creating a new node is equal to new node type. Okay, so we have our new node equal to node type. Since new node is a node, we can set its info equal to whatever, put a 50 there if we want. Okay. And now the next thing we have to do, we have to set the new node link. Okay. To be whatever we want to do. Okay. So we can point that anywhere. Okay. So ideally you'd want to go to the end, let's say, to the last node, and then hook that up to that last node's address. Okay. Can be the way you could hook these together. Okay. So let's take a look again at the textbook. It has pretty good illustrations. Hopefully they're not too small. Okay, so here we have our existing structure. So we've got head pointing to node 1, pointing to node 2, node 3, node 4. We've got a pointer that's currently pointing to the second node. Okay. And this new node here, we're creating a new node. It's totally separate from the first one. It's its own linked list. Okay. When we're setting the new node information equal to 50, that's setting it down here. Okay. When we're setting the new node equal to whatever p link was, okay, p points here, so p link points to the one with 34. Now this node is connected there. Okay. Now we need to set p link equal to that new node, and we have placed the new node within the existing linked list. Okay. So you have to know at what point that you want to do that. Okay. So when we're done, it ends up looking like this. Okay. So that is the basic idea that we're going to follow here. Okay. So when we're doing a deletion, we have some different questions to think about, but it's the same basic idea. Okay. And I went away too quick. Let me go ahead and save the textbook until we get all of the pictures out of the way. Then we can look at some code. Okay, so the idea of a deletion then, so we're at the case here where we have that the head node that points to these other nodes. P is currently on the second node. Okay. If we're going to delete the node that P's at, all we have to do is set P equal to P link. Okay, that's going to skip over the 65 and go straight to the 34. Okay. So there's again how this is going to work. Okay. Okay, now we're going to go back over to the computer. We're going to work on building up a linked list. Okay, so I'm going to go ahead. I'm not ready for my end domain yet. We were just playing around there, so we'll get rid of the stuff here. So we can create a function. We'll call this, it's of type, a node type pointer. That's the return type. We're going to call this build list forward. Takes no parameters. Okay. We're going to start by declaring some node type variables. One called first, called new node, and one called last. These are all pointers to node types. We have an int called num we're going to use. Okay. We're then going to have a message for the user. I'm going to have a cout, enter a list of integers ending with -999. Okay. We're then doing an indel on that. We're then going to cin num into that. Okay. We're starting off by letting our first be equal to the null pointer. That means it points to nothing. Okay. Then we've got here a while loop while the num is not equal to -999. Okay. So in case you didn't do this kind of structure, I don't always do it this way. This and the cin should be that way. We're going to enter a bunch of numbers with spaces between them. Okay. So we do that. Whenever we do a cin, it's going to pull the next one out. This is why we had to do a get line on that program the other day when we were looking for vowels. Okay. Because it's going to take them all separate. So it's going to be a list there waiting for us. We're going to pull one off at a time. Okay. So we now have the num is equal to the first number that was not -999. If it were -999, it would hit this and die. Okay. So we have this information. Let's say it's a 5 because it doesn't matter. I'm going to create a new node be equal to a new variable of node type. Okay. So I've created my new node. I'm going to have my new node. If I can spell it, new node. Keyboards jump around to me. info is equal to that number they've entered, first number they've entered. Okay. Then this new node, currently it's the only node, so therefore its link is now equal to the null pointer. Okay. But it's not capitalized. Okay. So we now have a new node called new node. We've added wherever we're at, we're adding its new link as a null pointer. Okay, we haven't. This is a new node that's not dealing with anything. It's kind of on its own. Okay, we've got an else in here. It's going to say that first is equal to the new node. Nope, that's not what I want. I can't have an else in a while. Here we go. Well, I'm skipping a whole section here. Okay, so I'm not doing my while yet. I jumped ahead. Okay, so I've got my new node. I've got it set up with the info pointing to number. It's a null pointer. Okay, there we go. Now, if first is equal to null pointer, so we have two cases here. If this is true, it means we have an empty list. Okay, nothing exists in our main list. Okay, so we're going to let first be equal to the new node. Okay, it's also true that the last is equal to the new node. Okay, if this is not true, it means we have an existing list. Okay, and we're tracking again the last node. So now the last link, so we're adding this to the end. The last links, we're going to hook up our new node. Okay, and now last is equal to new node. Okay, we're going to end our while, which means they've entered a negative 999, and now we're going to return first. Okay, so we're going to return that pointer to the first one. Okay, so let's go through this again. So we're going to build a list forward. Okay, so we're going to create pointers to node types called first, new node, and last. We're going to create an int called num. We're going to have the user enter series of numbers, series of integers, okay, ending with a negative 999. Okay, so we're then going to grab the first of those and call it num. Okay, we're then going to set up. First is going to point, so we have no nodes, right? We have nothing at this point. So first points to null pointer. There are no nodes, okay? And now as long as we haven't had a negative 999, we're going to go ahead and create a new node, okay? The first is going to function as the root in this case, or the head, okay? It's going to point to the first. We also have a last, okay? So we're going to look at creating our new node every time we go through. So we have a new node, with info, which is the next num that we have, and then the link is a null pointer. Okay, then we have two cases. If it's a brand new list and the first is points nowhere, then the first is now this new node and the last is equal to the new node and we're done. Okay, if not, which means we already have at least one, we're going to go to the last and set the last link pointing to this new node. And then the last then becomes the new node itself. Okay. So then we're going to return the first, which is a pointer, which we then can use later when we're doing stuff. Okay. There's also code in the book that we can build up a list backwards. Okay. But this one I think is okay. I think it makes some sense. Okay. So I think it may be worthwhile, as much as I don't want to do it, we can take a look at this. Let me share the whiteboard again. Our old buddy, the whiteboard. Okay. There we go. So let me clear everything. Okay. So to look at this code, and if you can follow along, if you have the book nearby, you can get an idea what this is talking about here. Okay. So we're starting off, I can do text, which is much better. We're starting off and we have a node pointer called first. So a pointer to a node type called first. We have another one called, I'm just putting the thing here so we know they're pointers. New node, we've set this up before we can use them. And then finally one called last. Okay. So when we start looking at the graphic here, we have nothing. Okay, so we have a little pointer called first, put an F in there. Okay, we've got another little one for our new node. Got another one for last. These are pointers, not nodes. Okay, they don't point to anything. Okay, so we ask the user to input the list of numbers. Okay, so let's say they've entered 3 space 45 space 65 space 2 space -999. Okay, that's what they've done. Okay, we're then going to cn the first number. So at this point, cn is going to point to the 3. The num is going to point to 3. Okay, we're seeing num, that's 3. Okay, so now we're getting down into our while loop. We're not at -999, so we're okay. So we're going to start by creating a new node. Okay, we're going to create our new node down here. It's our node construction area, roughly drawn as always. Okay, I'm going to draw them this way. We're going to set the info for that new node equal to num. Num currently points to 3. That's the world's worst 3, but you get the idea. Let me try this again. 3, there we go. Got a 3 there. Okay, we're then going to set this link equal to nothing. Okay, we now go into our if. If first points to null pointer, which it does, okay, then we're going to let first be equal to this address of the new node. Okay, new node also points here. Okay, we're also going to set last point to the new node. Okay, so after the first iteration, everything points there. Okay, we then are going to move our num to 45. Start the loop again. Okay, going to create a new node. Okay, wherever it's at in memory, we're going to create a new node. We're going to set its info equal to 45. We're going to set that equal to nothing, null pointer. Okay. We're now going to say if first is equal to null pointer. First is not equal to null pointer. Okay. So we're now in the second block where we're going to set last link. Okay. So last points to this node here. Last link is going to be in here. Okay. So last link, we're now going to be setting equal to new node. Okay, that's an ugly looking arrow, but you get the idea. So now last link points to the next one. Okay, we're also going to set last, this last pointer, equal to the new node. Okay, so I'm going to erase that, and instead, this is now going to point. That's not what I wanted to do. Let's undo that. I'm going to draw. This is going to now point to this node. Okay. So just so we're clear, first info is 3. First link info is 45. Okay. So we're now done with that iteration of the loop. And we're now equal to 65. Same idea. Going to create a new node. And I didn't keep up on this one. The new node, in fact, I'll just move that all together. The new node would have pointed to the new node. So I'm creating a new node over here. Okay, so my new node. I create the new node first with the next number, 65. I can make the 5 work, kinda. That's equal to the null pointer. Okay, the new node points to that. Okay, then again, first doesn't point to the null pointer. Okay, last points here. So I'm going to change the last pointer, the last link, sorry, to this new node, which is right here. Okay. And I'm going to move the last pointer will now point to the one over there. Okay. And that's how it's going to work. So we would do one more for 2, and it would be the same thing. Okay. If we wanted to print this out, we wouldn't change either first or last. Okay. I would start by declaring a new pointer. I'd say something like node type star current. I would set current equal first. Okay. And then, like we had before, I could have while current. It doesn't matter. I think I can go all the way. The current not equal to null pointer. It should be okay. Okay. Then I could print, so cout current info. Okay. And then I need to move it forward by saying current is equal to current link. Okay. And that should take me through. Okay. So when I start off, current is pointing to where first is. So current points to here. I'm going to, while current's not null pointer, it's not. Okay. So I'm going to cout current info, which is 3. Okay. I'm then going to set current equal to current link. Current link goes here. So current now points here. I'm still not at a null pointer. I'm going to print out 45. Current's equal to current links. I'm going to move it to here. It's now at 65. Okay. That's not a null pointer. Print out 65. Now current equals current link. Current link is now a null pointer. So current's equal to a null pointer. So this ends and we're done. Okay. So that's the basic idea of how this is going to operate for us. Okay, it's going to be able to create the link list in such a fashion. Okay. Okay, so let's go back over to our program we're working on. Okay. So we have the build list for it. We have it working. Okay, this would create the list all the way around. Okay, if we want to call this, all we should have to do, we should just have to say something like here, like, so we have to create something to hold this, right? So we have to say node type star list. And I can say list is equal to, I'll call that build list forward. Okay, that should return that. That should work. Let's see if that does work. I may be miles from working. I don't know. We'll see. Okay, so G++. All kinds of stuff. What doesn't it like? Oh, I've got the operator going the wrong way. When you get a whole page of information, usually that's what you've done. Yeah, you can't go both ways at once. Okay. Enter, so error 2, 3, 4, -999. Oh. This stops, don't know why, it doesn't do anything. I'm trapped there somewhere. Do a control C, see what I have it do. Okay. So it made it through there. That seems okay. This builds the list. It should stop when it does that. One thing we can check on here, this will be good information for us to know. When we create a new node, I'm going to go ahead and put a print line in here. So let me see out. And when I have code I know I'm going to want to get rid of later, I'm going to do something so I know to look for it. That's what I'm doing in this case. Oh, but anyway, I want the message to be creating new node for, okay, then I'm going to put a num in there. Okay. Not 100% sure why this is that, and I should have a -999, so I shouldn't be in an infinite loop, I don't think. We'll see why it's working or why it doesn't work. I may have a logic error there somewhere. But let's see what this does for us. Okay. So I do 1, 2, 3, let's say -999. Oh, there I'm getting stuck. Okay, we see where I'm getting stuck. It's the value of that. So when I'm doing the first one, oh, this is exactly what I'm not doing. Okay. I am not moving things forward here. Okay. What I'm missing here after my else before this, I'm never getting the next number. Okay. So I need to say CN none. Okay. So I'm glad I made that error. It shows you a way that we can catch that. Okay. So that's what's happening. That must be what was going on. And that was a runtime error, not a syntax error. So it didn't tell me about it. Okay, so let's try it now. If I do a 1, 2, 3, 4, -999. Yeah, it creates nodes for 1, 2, 3, and 4, and we're good. Okay. So let's go ahead and while we're at it, just to get an idea of how this works. If I create, I'll just print it out here. I won't do a print function. Okay, so we now have so in addition to list, let's create current as well. Okay, we're going to use that. So we've built the list now. Okay, so we're going to go through this list. We're going to say current is equal to list. Okay, that's going to be the first thing that we have. We're going to have a while current not equal to null pointer. Going to see out current info. Put in a little link thing there to try to be fancy on my graphics. Okay, I've printed it out. Now I'm going to let current equal to the current link to move us forward. Should do it. Okay, let's see if this works. compiled. Okay, I'm gonna run through, do 1, 2, 3, 4, 5 this time. -9, 9, 9. And there you see. Okay. Because I'm picky, I don't want an indel there. Okay, I'm going to go ahead and get rid of this now. Okay, I'm working, so I don't need that line. And then in my printout, I don't want an indel there. I want to have it on the same line. So let me fix that. And then when I'm done with that, then I'll do, don't like to leave people at the end of the line. One, 2, 3, 4, 5. -9, 9. There you go. Still have trouble. I've got one extra arrow, but we could deal with that. You get the idea. Okay. So hopefully you have more of an idea of how the linked lists work, and we'll do some examples in class, but I wanted to give you some basic information to get you going first. Okay.